Hello, my name is Freddie, and welcome to our LEC 3907 presentation, where we will be introducing our metal detecting rover. Our group consists of 5 members: Julian, Brendan, Gaurav, Josh, Shehan, and myself. So let's get right into it. As you can see, we decided to split our rover into 5 subsections, and I will be highlighting the purpose of each subsection. First comes our power. Here we use a portable USB battery pack which operates at 6000 milliamps at 5 volts, which is also connected to a buck boost converter to boost up to 12 volts. Our second subsection is our motor drivers. We use a dual H-bridge motor drivers, which allows us to control the direction and speed of the motors. Our rover tracks, which were 3D printed, are able to give us the accuracy and precision we need. By using tracks, we allow for better maneuverability with a 0 turn radius, a higher level of traction, and an overall smoother ride. And we also use a Bluetooth controller to control the movement of the rover. Our third subsection is our BN880 GPS module, which gives us an accurate location using NMEA data, which we then translate to our latitude and longitude coordinates, which we can use to track our rover's movement at all times and pin locations when metal is detected. Next comes our metal detecting subsystem, where we use cold plate oscillators to detect metal objects. It's made from 2 components, a tank circuit for oscillation and a BJT inverting amplifier to keep the tank circuit in oscillation. When a metal object is near the inductor coil, the permeability of the coil changes, which causes a change in inductance and thus a change in frequency. It will store the fixed frequency and compare the incoming frequency of the detector circuit to the stored frequency. The sensitivity potentiometer will be set up as a voltage divider that will be read by the Arduino's analog pin. This Arduino Nano will be connected to our ESP32 camera, which is our 5th and final subsection. We use the ESP32 camera module as our main microcontroller, as it is what integrates all of our subsections together. Our graphical user interface works by connecting to our ESP32 wirelessly through a router, which we can then use to connect our UI to. Our UI consists of a live camera feed on the right hand side of the screen, which transmits live data over Rover, a live feed of a map which tracks the route of the rover at all times on the left hand side of your screen. On the bottom left of your screen, you'll see a GUI of our Bluetooth controller to let the user know which buttons are being clicked in real time. And finally, once a metal is detected, the user is notified with a message which pops up on the bottom right of your screen, and then that location is then pinned onto the map. As you can see on your screen, whenever metal is detected, a red dot appears on the map and the route of the rover is tracked at all times and pinned with blue dots. On the bottom left of your screen, you can see our GUI, which reads out important information like the coordinates of the rover, the altitude, as well as the estimated speed of the rover. All of this can be critical to the user when the rover is deployed into the field. Our rover also has capabilities to be used at nighttime with our integrated flashlight, which can be turned on and off by the user with the press of a button. Everything for our project is encapsulated into our rover frame, which was also 3D printed to our custom needs to be able to host all of our subsections together, while also staying lightweight and small in shape to stay undetected in the field. And this summarizes everything about our metal detecting rover, and we'd like to thank you for listening to our project.